Thank you so much for joining this lesson. We shall be discussing the Alliance Mathematics Forum Examinations, Mathematics Paper 2, Section 2, the Post-Mock 2025. So please join me in this serious discussion. It's my hope that you guys are going to learn a lot from this paper. The Section 2, number 17. You know, we are supposed to use the best 5 questions according to ourselves, but allow me attend to all the questions so that now, from the understanding of everything, students now will be in a good position to gauge themselves and make a choice of their best 5, depending on the simplicity or complexity of a certain area. Number 17. Mercy bought 3 brands of perfume, A, B, and C. The cost of the 3 brands were 25, 30, and 45 Kenya shillings per millimeter, respectively. She mixed the 3 brands in the ratio 5:2:1, respectively. After selling a mixture, she made a profit of 20%. Part A, how much profit did she make per millimeter of the mixture? Let's look at these. We're supposed to, 1, understand the cost of a millimeter of this particular mixture, whereby 5 proportions are for brand A. So 5 proportions, each 25, then 2 proportions, each costing 30, and 1 proportion, each costing 45. That will be the total cost of the mixture. But now the mixture per millimeter shall be divided by 5, 2, and 1. So at this point now, we can compute all these and come up with, let me just multiply. So we have 5 by 25 plus 2 into 30 plus 45 by 1, 230. Then this will be divided by 8. So a millimeter of the mixture will be costing 28.75 Kenya shillings. Then now, this particular business lady, Mercy, wants to make a profit of 20%. So we would say that the cost price is 100%, equivalent to 28.75. What about 120? Okay, how much profit did she make? So we can get the profit itself instead of the selling price. Instead of the selling price, we can get the 20%, which is now the profit. 28.75 times 20 over 100. So that we directly get the profit itself. So we multiply this by 20 over 100, giving us 5.75. Yeah, 5.75 Kenya shillings per millimeter of a mixture. So that is how you are supposed to navigate through the part 1, giving us a total of 4 marks. A very simple question. Part B, together. After 1 year, the cost price of each brand increased by 10%. For how much did she sell 1 millimeter of the mixture to make a profit of 15%? Give your answer to the nearest 5 cents. Therefore now, brand A, instead of costing 25, it increased by 10%. So brand A started costing, it was 25. So it increased by 10%. It became 110% of the original. So 25 by 110%, giving us 27 shillings and 50 cents. Then B, which was initially costing 30, now started costing what? 30, 110% of these. We compute 30, get 33 Kenya shillings. The next is going to be 45, whereby now C will be costing 45 times 110% of the original. And this is giving us exactly 49.50 that way. This is now the new mixtures. Okay, the new cost. Assuming that now she is going to sell, or she's going to mix in the original ratios. Yeah, the ratios will remain for mixing. Then we will have now 25. Not 25, but 5 proportions according to the ratio. 5 proportions, 27.5. Then 2 proportions at 33. Then 1 proportion at 49.5. Then now we have to divide. We have to divide by 8 again. Yeah, divide by 8. So 5 into 27.5. Then we add 2 into 33. Then we add 49.5. 253. This now should be divided by 8. So I'm getting 31 point. And I hope that multiplication has properly been done. Yeah, 31.625 Kenya shillings. This is how now a mixture is costing. Now she intends to make a profit of 15%. Yeah. Selling price. So we will say this cost price of a millimeter of the mixture is costing 31.625 and should be the 100%. What about 115% such that we have the price inclusive of the profit made to give us the selling price instead of calculating the profit independently to add it later? We can compute directly to go to the selling price. So this should be multiplied by 115 over 100, giving us 36.37. 36.37. But because we are advised to the nearest 5 cents, then we shall talk about 3.5 Kenya shillings. Yeah, 3.5 Kenya shillings. Roman 3, no, Roman 2 of part B, yeah. What would have been our percentage profit if she sold 1 millimeter of the mixture at 45? That is now in this second case. We say 100% equals to 31.625. What if we take the selling price to 45 Kenya shillings? What percentage will it be equivalent to? This one can be computed very quickly, and you realize that the percentage profit shall be, so we multiply 45 by 100 out of 31.625. This gives us 142.29. Meaning that now the percentage profit shall be 42.29%. So this would be now the new percentage of the profit. We are transitioning to number 18, a serious question on transformations. Therefore, we're going to dive into this question, but as we continue learning, kindly allow me bring to your attention some of our programs for the holiday. We have the Shifting Grades Online School. We're calling it the One Term Ahead program, whereby we'll be having Google Meet classes from the 20th of November to 12th December. This is 5 weeks of thorough work covering the term 1 work of 2026. The target groups are the JS and also the senior school. So please reach out through the number. It's already attached here, 0704 15 3366. Just reach out so that you may get in touch with us, meet qualified teachers so that you may get to know what you need at that particular time. By the time you'll be opening for 2026 term 1, you shall be 1 term ahead of the others. So please join us and get the best from the best. We are also having the candidates program 2025 every Sunday from 7:30 to 9 p.m. Reach out through the same number for more consultations. The interaction is via Google Meet. Very interactive forum, just like an ordinary classroom. You get to ask questions, you get to answer questions, you get to seek clarity about whatever is being explained. Now to number 18, the points. A, 1, 1, 2, 2, -3, and C, 3, 0 are the vertices of ABC. That's a triangle, I suppose. Find the coordinates of the vertices of its image, A, B, C prime, and a transformation defined by the matrix 3, 0, 1, 1. Then part 2, draw the object and its image on the grid provided. So we'll get to utilize the grid. Let's first find the coordinates of the image. We're supposed to know that a matrix of transformation multiplied by object should give us image. Thereby, we can talk of 3, 0, 1, 1. This one now multiplied by the coordinates of A, 1, 1, is a column vector. Coordinates of B, 2, -2. Those of C, 3, 0. So now we perform this multiplication. We know very well that to multiply matrices, we need row times column to get the first element. So this row times the first column. So 3 by 1 and 0 by 1. That means 3 times 1 is 3 and 0 by 1 is 0. So we get 3. The next element should be the same row by the next column. So 3 by 2 and 0 by -3. 3 by 2 gives us 6. But 0 by -3 becomes 0. So when you add, you remain at 6. Look at this. We shall be having 3 by 3 and 0 by 0. 3 by 3 is 9. Then 0 by 0 is 0. So we can't add anything there. We enclose our brackets and proceed with the multiplication. The second row by all the columns so that you may get the Y values now of every coordinate. So 1 by 1 plus 1 by 1. That's 1 plus 1, giving us 2. The next shall be 1 by 2 and 1 by -3, giving us 2 minus 3, which is a -1. Then 1 by 3 and 1 by 0, giving us 3 plus 0, which is a 3. So now we have to list as coordinates. A prime is 3, 2. B prime, 6, -1. Then C prime is 9, 3. So we have the coordinates of the image triangle of ABC. Look at the second assignment of drawing the object together with its image. We just proceed to that. Let's proceed to that. We utilize the Cartesian plane very well. Let me zoom it to ensure that everything that we are doing is visible from that particular end. I hope you guys are subscribing to our platform. In case you have a friend who is in secondary school, who is in JS, kindly invite them to our serious programs. Just talk to them, let them know about shifting grades. This is where people get transformed. This is where people get their best. This is the home of academics. So kindly join us together with your friends in the next presentation. We'll continue preparing you until you sit for the national examinations. So you're most welcome, you and your friends. I'm just labeling the Cartesian plane, you know. Yeah, I think that's enough. Then on the vertical axis, we can have 1, 2, 3, 4. On this other one, we can have -1, -2, -3, -4, -5, -6, -7, -8. Yeah. So on the y part, maybe we might require greater values than -8. So allow me raise the y-axis, not the x-axis, to some reasonable point, affecting the labeling of the y-axis. So the x-axis can be raised to begin at a higher level than that. So we shall be talking about the axis being at a point here. This is a 0 now. 1, 2, 3. We begin from there. -1, -2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's enough. -1, -2, -3, -4, -5, -6, -7, -8. -7, -8, -10, like that. Then now we start the plotting of the coordinates. So we start with the 1, 1, 2, -3. So this is coordinate 1, 1. Then 2, -3. The coordinate is at this point. A, B. It's good to label the coordinates immediately you identify them, even before you come up with the diagram. After you identify coordinate A, label it at that point. Then you proceed to B like that. Then the C is 3, 0. So this is the point. 3, 0 like that. Now I can do in using a different color, of course, to get ABC as a triangle. That's the first triangle. Then now that we've computed the coordinates of the image after the first transformation, we can plot the second. 3, 2. So we start with 3, 2. This gives us A prime. We proceed to 6, -1. So 6, -1 at this point. So our B prime. Then C is at 9, 3. So 9, 3 is at a point like this, C prime. And now we connect to get this particular image. So let me connect. If there is one of the topics where a student can scoop very serious marks without even struggling, is this particular topic. Anyway, we can now proceed to check what part C is asking. Look, we are told that the triangle ABC prime is then transformed to triangle A double prime, B double prime, and C double prime by the transformation matrix 1, 0, -1, 3. Part 1, write down the coordinates of A double prime, B double prime, and C double prime. Let's compute that together. We start again by matrix 1, 0, -1, 3. This should be multiplied by the object, which is now the first image here. So A prime now becomes the object, 3, 2. B prime, 6, -1. C prime, 9, 3. Let's look at this multiplication. As usual, row times column give us the elements. So this row times the first column here 1 by 3 and 0 by 2. This shall give us 3 plus 0, which is just 3. The next shall be 1 by 6 and 0 by negative 1, giving us 6 plus 0, so 6. And finally, we have 1 by 9 and 0 by 3, giving us 9. Then we proceed to the Y, whereby we should use the second row in the matrix, the transformation matrix, times the first column. Negative 1 goes by 3 and 3 by 2. So negative 3 plus 6, giving us 3. Negative 3 plus 6, that way. Then the same row and the next column here, whereby we will talk about negative 1 by 6 and 3 by negative 1. So that's negative 6 minus 3, giving us a negative 9. And finally, negative 1 by 9 and 3 by 3. That will give us minus 9 plus 9, making it a 0. That way. So now we can list coordinates. A double prime shall be given as 3, 3. Then we talk about B double prime, giving us 6, negative 1. And finally, C double prime. C double prime is giving us 9, 0. Yeah, 9, 0, like that. So with this, with this, we can now, actually the coordinates have already been listed. We can check what part 2 demands. Draw the triangle A double prime, B double prime, C double prime on the same grid, Then describe the matrix that transforms the double prime back to the original image. So now we can turn off. Let me first plot it. So we'll be having 3, 3 as the first coordinate. That is where A double prime shall be. Then 6, negative 9. 6, negative 9. This is where B double prime is. And finally, C. C is at 9, 0. This is C double prime. So we can get now the second image plotted. A to B, let's see, very straight line. A to B like that. Then B to C. And back to A. See, now we have all the triangles properly plotted. A very decent plotting. Look at that. Very good work. Now with this, look at the other question now. Describe fully the transformation that transforms the double image back to the original triangle. One thing that you're supposed to understand here is that we can use geometry to get to know what we need here. First, we can see that it is an enlargement. So what we are doing is now looking at the enlargement scale factor and all that. But technically, you're supposed to be very sharp in this one, because you must understand that now the second image is being treated as the object, so that it is mapped back to the original image, which now is becoming the original object, now becoming image. Therefore, it's this one being marked to this. It is not a, let me call this one 1, then this one is called 2. So we are mapping 2 into 1, meaning that the enlargement scale factor is going to reduce this. So let's join B to B prime first. We want to see what kind of an enlargement is this. B to B prime, then we just Just extend like that. Then we can do the same for A. A double prime. We join and we extend. Like that. See, A and the image of A are meeting somewhere together with B. They are meeting at center. Therefore, we can say that this is an enlargement first. We mention the nature enlargement. Center 0, 0. That is the origin. Then the scale factor. We consider the distance from the center to the image, and we divide it by image, by the distance from the same center to where the object was. So if we consider the B's, then we'll be moving from this point all the way to where B is, that way. And you can see it's within 3, 2 squares. Then we check from the same center to where B prime is, and we divide. And you discover that the distance is 3 times the other one. Therefore, the scale factor is a third. The scale factor is a third. If it was, look at this, if it was mapping 1 to 2, it would have been a positive scale factor of 2. It would have been a scale factor of 3, positive. But now that it is 2 being mapped onto 1, then it's a third. A very good question. This is now a third. We are changing very quickly to number 19. And just to question, have you uploaded airtime to your line? Safaricom, Airtel, Telcom. You just go to your Lipa na M-Pesa option, the pay bill number 737356, then the account number is the phone number that you're purchasing the airtime for. Remember, it could even be the phone number of a friend, as long as you write it well, and that's where you intend the airtime to be remitted to. Then you proceed with the transaction by entering the amount, complete the transaction, then the airtime shall be received instantly by the line that you've written as the account number. So finally, promote this by simply purchasing the amount that you want for airtime in a minute. In the blink of an eye, your airtime shall be remitted to your respective line. Looking at number 19 now, the cash price of a TV is 24,000. It can also be bought using either of the two plans below. Look at part A. We have a plan which is said to be a deposit of 6,000 and 15 monthly installments. Plan B, 20 equal monthly installments of 1680 Kenya shillings each. Part A of this question now is asking us if the total payment in plan A is 25% more than the cash price. Find part 1, the amount of each installment. So in plan A, it's 25% than the cash price. So 125% of the cash price, which is 24,000. How much does this give us? This is going to be 125 over 100. We multiply this by 24,000, giving us 30,000. So when you use plan A, you shall pay 30,000. And if you pay 30,000 there, and already there is a deposit of 6,000, can we check the installments? Installments shall be 30,000, and we subtract the deposit that you have to make first. So when you subtract 6,000 from 30K, you're getting 24,000 as the total installments. Once you've gotten the total installments, now you can find the amount of each installment by simply noting that they were 15 monthly installments. They have totaled to 24,000. So each installment shall now be 24,000 out of 15 months. giving us each installment as 1,600. 1,600 Kenya shillings. Part 2. That's a very interesting part. It's my hope that you're really coordinating what we are doing at that point. It's also good for you to remember that our consultation line remains 0704 15 33 66. So that's our consultation line. Proceeding to part 2 of this, the annual rate of compound interest. The annual rate of compound interest, and that is for plan A. Yeah, we're sticking to plan A. So when we talk about compound interest, where higher purchase has been involved, we usually say that after you make a deposit, there is a balance that remains. This balance is what earns interest, and it's usually paid later as total installments. So balance becomes principal, and total installments become the final amount that you end up paying, meaning that the balance has earned some interest. So once a down payment in plan A was made, the balance from cash price of 24,000 after making a down payment of 6K, this balance becomes our principal, and it's what shall earn interest now. The 18,000 that we are getting here, this is what shall earn interest. So we can call it technically this is now our principal. Then total installments in this particular plan now become the amount. So amount shall be, amount is going to be, we look at the amount whereby it is the total installments. Total installments, we've already worked out 24,000. So now in this case, we'll be saying, remember the compound interest formula? Says amount equals to principal into rate plus 1. The rate is 100 plus 1. Then we raise everything to power n. So this amount is coming from a principal equivalent to 18,000 into 1 plus a rate which is unknown, raised to 15 months. You see that? So we can first now take 24,000. We divide by 18,000 to give us 1.333 recurring, equals to 1 plus R over 100 raised to 15. Now that this is raised to 15, we can take the 15th root on both sides. Now we take 15th root. So 15 shift power. That's what you type. You get 1.0194 equal to 1 plus rate over 100. We have obtained the 15th root. So power 15 is now not there. We subtract, we get 0.0194. This is equal to R over 100. How will you get R? You multiply by 100 both sides, 94, and this is per month. But now this examiner wants it as annual. So annual rate, we multiply this by 12 months so that you may know what it is per annum. This gives me exactly 23.28%. So that is now the rate of compound interest. And let it be taken clearly, let it be known that in this particular case, for you to apply the compound interest formula where higher purchase has been involved, then we say balance after down payment is our principal because that's what shall earn interest, and the total installments that will later be paid becomes now the amount. So meaning that, or implying that, the principal, which was the balance, has now earned some interest until it's being paid as an amount, which is now the total instruments, higher than the balance that would have been paid at the initial stage of the plan. Find the annual rate of compound interest in Plan B. Look at Plan B. In Plan B, there is no deposit being made. 20 equal monthly installments, 1680. So the initial cash price is our principal. So we can check the amount, which is the 20 by 1680. So the amount that will be paid will be 20 by 1680. See, 20 by 1680, giving us 33,600. That is now what you will pay. And the principal, how much would have been paid if it was not for the hire purchase plan, this one. What would be the rate? Remember, this is 20 monthly installments, 20 monthly installments. So we'll talk up 23. We use the same formula. 33,600 equals to 24,000 into 1 plus rate unknown raised to 20 months. When we divide this by 24,000, we are getting 1.4 exactly, equals to 1 plus rate over 100. This is now being raised to 20. So at this stage, we can take 20th roots. So 20 shift power, which is giving us 1.016966 equals to 1 plus rate over 100. The 20th root has been obtained, so we don't have power 20. We subtract here to get 0.1, 0.16966 equals to rate of 100 after subtracting 1 from both sides. How will you remain with R? We are supposed to multiply through by 100 to give you 1.6966. Then the rate now per annum shall be, we multiply by 12. This gives us 20.36%, and this is now per annum. This was per month. So we are supposed to arrive at the answer per annum. And finally, looking at part C of this question, which plan is cheaper and by how much? Now, you can see that in Plan B, at the end of the day, we are paying 33,600. But in Plan A, the total payment shall be 30,000. Therefore, Plan A is cheaper. And by 33,600 minus 30,000. So it's cheaper by 3,600. The best plan, according to what we add in this electronics shop. Plan A is cheaper, and it's cheaper by 36,000. A very good question. Very good question. Looking at number 20 now on statistics. The table below shows the distribution of wages in a week for 50 employees in a certain factory. So we have the wages. You can see them in classes. Then after that, we have the number of workers, which is the frequency in this case, using 1049.5 as the assumed wage. Calculate the mean for this particular group, then calculate also the standard deviation of the wages and also estimate the quartile deviation for the grouped data. So let's check into these. We're supposed to manipulate the table to have it in a different format so that it enables us to work out the many statistical measures that are required. So let's go. Let's go. We can have the classes there, their respective frequencies at that point. Then after that, because it's mean, we can't fail to work X, the midpoint. Then we can't fail to work the difference between midpoint and the assumed mean. Work them out there. Then now FT, frequency times each different from assumed mean. And after that, we can talk about FT squared and CF finally, and CF. So we shall fill the table step by step, depending on what we are computing at a particular time. So let me begin by the classes here. The frequency at this point, the midpoint of a class, then T, which is the difference between a midpoint and the assumed mean. Every midpoint and assumed mean that way. Then we can get FT. After that, we'll be getting, now for standard deviation, FT squared. And finally, we'll be getting CF for the quartile deviation. So let's begin with listing all the classes. 800 to 899. Then 900 to 999. Then 1,000 to what? We check that. 1,000 to 1099. 1,000 to 1099. Then 1100 all the way to 1199. Then 1200 to 1299. These are the classes properly displayed. It would be better if I do a very straight line across here so that every class is well distinct. To distinguish all the classes, it's good we do these proper lines. Very good to do these proper lines. Interesting, interesting. Now we have all the classes properly distributed. 3, 10, 25. 9, 3. That's how the workers have been distributed. Let's find the midpoint of every class. How do we get midpoints? We are supposed to take the limits we add and divide by 2. 800 plus 899 over 2. That gives us 849.5. The next shall be 900 and 999 divided by 2. Get 949.5. The next shall be 1,000 plus 1099, and we divide by 2. We get 1049.5. Then 1100 and 1199, we divide by 2. We get 1149.5. Then 1200 and 1299, we divide by 2. We get 1249.5 that way. So with the midpoints, we can get how each midpoint varies from the assumed mean of 1049.5. So in the first case, we'll have a negative 200, then negative 100, then 00, then positive 100, and this is 200. That's how the deviations are. From there, we get FT. 3 times negative 200, we get negative 600. 10 times negative 100, we get negative 1,000. 25 by 0, we just get a 0. 9 by 100, we get 900. 3 by 2,000, we get 6. 200. Yeah, FT, that too. Now we proceed to work out part 1. Let me work out Roman 1 here. Mean is usually given by assumed mean plus summation of FT. Summation of F. So here we'll talk about 1049.5 plus summation of FT. Now, when we add up FT here, we shall be getting negative 100. Yeah. Then when we add up the frequencies, the first frequency is 3. The second frequency is 10. So you add to get 13. 13 plus the next frequency here, 25, get 38. 38 plus the next, which is a 9, we get 47. 47 plus the last, which is a 3, we get 50. So frequencies are totaling to 50, just as we had been told. So negative 100 out of 50. This will give us 1049.5 minus, okay, plus a negative 2, giving us, I think, 1047.5. That is now the mean. And from the same space, we can work out Roman 2 now. See, Roman 2 is requiring standard deviation, which requires the square root of variance. You get that? Standard deviation that requires the square root of variance. Therefore, variance is usually given by summation of f of t squared out of summation of f, then minus summation of f t over summation of f, this one now squared. Now we need this and also its square root at the same time. So this is variance, but now to get standard deviation, we have to proceed to the square root of this. This is what will give us the standard deviation. Therefore, we can get f of t squared. So f multiplied by each t squared. If it's 3, it should multiply negative 200 squared. So 3 times 200 squared, giving me 120,000. Now, when we proceed to 10, 10 is the frequency, should multiply negative 100 squared. This gives us 100,000. The next should become 0 because 25 times 0 squared is just a 0. 9 as frequency should multiply 100 squared, giving us 90,000. And finally, 3 should multiply 200 squared, which is 120 squared. So we add up now summation of f t squared. So adding up everything, we should slowly and for sure confirm the totals as 430,000. So now we get to the formula now and talk about 430,000 out of 50 minus, this is negative 100 out of 50 because we had worked out and we square. Then we shall be obtaining the square root now later. When we take 430,000 and we divide by 50, we're getting 8600 minus, I take negative 100, I divide by 50, I get negative 2, and I square the answer. I get 4. This will be 8600 minus 4, giving us, remember the square rooting, the square root of 8596. This will give us the square root of 8596. Square root shall give us 92.71. 92.7. This is now the standard deviation. The standard deviation. A very interesting question. Please be prepared for statistics too. Even if you will not get this kind of a question, you will not lack something that we call the ogive, which is the cumulative frequency curve. So kindly just be set for statistics too in paper 2, mathematics, KCSE 2025. My humble submission anyway. See, now we are in the last part of this statistics question, whereby we are estimating the quartile deviation. Remember, quartile deviation is also called the semi-interquartile range and is given by Q3 minus Q1 out of 2. meaning that we have to proceed to estimate all this. Q3 is 3/4 of data, and we usually give it by lower class boundary of the Q3 class plus 3/4 of n, Q3. 3/4 of n minus cumulative frequency before that class times frequency multiplied by class wing, like that. So we can get this one by going to we go to the CF and check 3/4 of this data. 3/4 of 50 workers. 3 out of 4 of 50 workers, giving us 37.5, technically the 38th worker. So where is the 38th worker accommodated? 38th worker will be accommodated in this class. If 38th worker is accommodated in that class, then that is the class that will give us Q3. So the lower boundary of this class, you know, the Q3 class is here. We do identify it. Q3 class is that one. So this Q3 class is going to give us a lower boundary of 999.5. 999.5 plus 3/4 of these 3/4 of 50 minus cumulative frequency just before. Cumulative frequency just before is 13. Out of frequency of this class, frequency of the class is 25. Then multiplied by the class width, which is 100. The class width is 100. The class width of 100, that too. So we can compute the Q3. We subtract 13. We multiply by 100 and we divide by 25, giving us 98 plus. Now this will be 999.5 and we add 98. This gives us 1097.5. That is the Q3. What about Q1? Q1 shall be given by lower boundary of the Q1 class, 1/4 of total frequency minus C times frequency of the Q1 class multiplied by the class width. What is the Q1 class? 1/4 of this total population. 1/4 of 50. What are we getting as 1/4 of 50? This is 12.5. Technically the 13th. Where is the 13th worker accommodated? And it's in this class. That's where the 13th worker is accommodated. So we talk about the lower boundary of 899.5. 899.5 plus 1/4 of 50 minus cumulative frequency just before. Just before that, we have 3 out of frequency for this particular class. Frequency for this class is 10. Frequency is 10 here. Then multiplied by 100 as the class width. So we can compute all that. 899.5 plus 12.5 minus 3. We multiply by 100 and we divide by 10, giving us 95. So when we add to 95, 899.5, I'm getting 994.5. So we have Q1 and Q3. So we take now quartile deviation as 1097.5 minus 994.5 out of 2. So 1097.5 minus 994.5, then I divide by 2, 51.50. 51.50. That is the That is the quartile deviation for the available data. Yeah, the quartile deviation. That's simple. That's simple. So it's good for you to know what you're doing. It's good for me to also talk about how do we arrive at the lower boundary of a given class. To arrive at the lower boundary, we are supposed to take lower limit of this class plus previous upper limit, and we divide by 2. To get lower class boundary, you take the lower limit of the class plus the previous upper limit, and you divide by 2. For example, for this Q1 class, which is here, we had to take 900 as the lower limit, and the previous lower limit of 899. Then you divide by 2. You get 899.5. For the Q3, we had to take the lower limit of 1,000. We add the previous upper limit, 999, and we divide by 2. We get 999.5. Even when calculating the median, that is the approach you're supposed to get. That way, you will not be confused, even when the data is continuous. This is discrete data. And even when it's continuous and you apply the same, lower boundary is given by lower limit of the class plus previous upper limit. Then you divide by 2. You will never get lost in such case. Thank you. Thank you for being around in this particular class. Remember, 0704153366, our main line. So kindly reach out for our programs. You get to learn the best. Remember, if you're a candidate and you're following us and you are in day school, you can get the best as we continue preparing for the KCSE. Right now, you'd be raising up your hands to ask for questions, to ask for clarity whenever you don't understand. But now I bring such an opportunity on every Sunday from 7:30 p.m. to 9 p.m. So please reach out through our line, which is already displayed on the board, 0704153366. Get to know the best from the best, of course. Number 21. Yeah, number 21, a question on probability. Let's get to it. What does it have? This probability question. What does it have? So the question says that in driving to work, Wekesho has to pass through 3 sets of traffic lights. The probability that she will have to stop at any of the lights is 3 out of 5. Part 1, draw a tree diagram to represent the above information. So we have the first light, the second one, like that. So now we talk about Wekesho in the first light. Passing the 3 lights. She will have to stop. Probability of stopping. So she can stop or stop not. Stopping is 3 over 5. Meaning that not stopping is 2 over 5. These are what we call mutually exclusive events, whereby their probability should add up to 1. The 2 cannot occur at the same time. She has either to stop or to stop not. So if she stops at a probability of 3 over 5, then not stopping should be 2 over 5. Now that is from the first one. In the second one, we proceed. She can either stop or still stop not, and the probability is the same. This is now an independent event. 3 over 5, 2 over 5, and whether she had stopped, she can still stop in the next or stop not at the same probabilities, like that. Then finally, the third one, because they are 3. At this point, we can talk of stopping, stopping not. 3 over 5, 2 over 5. At this point, stopping, stopping not, stopping, 3 over 5. Then 2 over 5. Here, we have the same stopping, stopping not. So 3 over 5, 2 over 5. And finally, can have stopping, stopping not. Stopping is 3/5, not stopping 2/5. So you indicate the probabilities along the branches and the outcome at the end of the branch. If we have to analyze everything at the end of this branch, from the first branch, which is ending with S, it is stopping, stopping, stopping. Then the second one, stopping, stopping, not stopping. The third one is stopping, not stopping, stopping. This one is stopping and not stopping in the other two. Then we have a not stopping, but stopping in the other two. Not stopping, stopping, not stopping, then stopping. Okay. Let me align well. This is for this. So from there, that's where we are almost losing it now. So we're supposed to have these, whereby it starts with not stopping, stopping, not stopping. Then for this one ending here, not stopping, not stopping, but stopping. And finally, stopping in all of them. Not stopping in all of them. Like that. So we have all the outcomes now outlined. Remember, this is just extra work for your own benefits. If you're working out such a question, it's good to outline all the outcomes at the end of it. So that now when you respond to the questions thereafter, you don't even struggle in anything. You don't struggle. Everything is just smooth. Part B, using the tree diagram now, determine the probability that on any one journey she will have to stop at. She will have to stop at all the three sets. So probability stopping in all of them, which is 3/5, 3/5, 3/5. This is going to be exactly when we can multiply this, we get 27/125. Yeah, like that. Then in the next, it's a probability that she will have to stop only one of the sets, stopping in only one. Meaning that it could be probability stopping, but the others she passes, or probability you pass, stop, and stop again, because we want that she stops in one of them, only one, or you fail to stop, but stop in the last. As long as there is one stopping, that's what we get. That means we need 3/5, then 2/5s. Or 2/5, 3/5, then back to 2/5, or, which means addition, 2/5, 2/5, 3/5, that way. So now we add. Whenever you see or in probability, should be addition. We talk about addition. 12 out of 125 by 3. You add everything. So this is equivalent to multiplying by 3. And this will give us 36 out of 125. Yeah, 36/125. Look at Roman 2. No, Roman 3 now. The probability that she will have to stop at only 2. Stopping at only 2, again, we have to check what we are doing there. Stopping at any 2 means probability she can stop in the first 2, but not stop. Or probability stop in the first, pass in the second, and stop there. Or probability we can have her failing to stop, but now stopping in the other 2. Yeah, stopping in the other 2. So again, almost something the same. Stopping is 3/5. times 3 over 5 times 2 over 5, or which means addition, stopping, not stopping, stopping, or not stopping, then stopping in the other two. So what will you get in this one? You have to work out it smart. 18 over 125 by 3. 18 over 125. And there are 3 possible options which are the same. So this will give us exactly 54 out of 125. Very simple working. She will have to stop in none of them. So probability, no stopping at all. So it's 2 over 5 by 2 over 5. This will give us 8 out of 125. And 8 over 125. Very simple. Very simple. That was number 21. A very decent question. Very decent question. We are proceeding to a very wonderful item here. Very wonderful. And this is what we call angle properties of circles, together with tangents and chords. In the figure below, we are told that O is the center of the circle. Then we are told that A, B, C, and D are points on the circumference of the circle. Then A, O, X, and C are points on a straight line. That's a straight line up to E. Then DE is a tangent to the circle at point D. Angle BOC is 48, just as indicated in the diagram. CAD is 36, still as indicated. Now look at this now. Giving reasons in each case, find the value of the following angle. CBA, the angle CBA, meaning that we are supposed to look at a lot here. We can connect. Then we also connect here. Let me do a straight line like that. And also have this one so that we're having what we call. Look at that. So the angles CBA means the whole of this angle. The whole of that. Remember, we usually say that angles subtended by the diameter. Angles subtended by the diameter to the center of a circle are to the circumference of a circle are usually right angled. So the angle is 90 degrees. Reason being, angle subtended by diameter. Angle subtended by diameter that way. Then the next angle, BDE. BDE, it means the whole of these. Yeah, BDE, that is the angle. There, we shall move slowly. Remember, we are having 48 already, so we can get the other angle on this side by taking 180 minus 48. That gives us 132. 132. Now we can consider the triangle from point, triangle AOB. AOB means these are what we call isosceles triangles. We should get 180, yes, in that triangle. So we have to take 180, we subtract 132. So that we talk about 48. Then the 48 is divided here. 24, 24, like that. So if those are equivalent to, those angles are equivalent to 24 each, then the whole angle at point A shall be equal to 24 plus 36. This gives us exactly 60. So the whole of this angle is 60. The whole of this angle at A, 60 degrees. With that angle at 60 degrees, look at the angle BDE. that angle has been subtended by the same chord with a tangent. So we can say this angle is equal to 60, and I'll show you how to give the reason. Angle subtended by chord and tangent is equal to angle by the same chord in the alternate segment. In the alternate segment. Yeah, we call it alternate segment. Therefore, this is what we call the alternate segment. So if the chord BD is making an angle with a tangent DE, then the same chord BD is producing an angle in the alternate segment. Then those two angles are equal. Technically, I can have it explained here. This is our BD, and we are having a certain tangent passing at D, such that now there is an angle formed here. This particular angle is equal to any other angle that might be produced by the same chord, but now in the opposite, okay, in the alternate segment. So these two angles are going to be equal. That is mathematically proven. Mathematically proven. We are also finding a certain angle here. We are finding the angle CED. Let's look at that. CED. This one. This one. CED. For this one, we can use a lot of approaches. Yeah, a lot of approaches. Remember, we have already gotten 60 here. And we can also talk about the angle at this point being half the angle at the center. Now, the chord A to B is producing 132. 132 at the center. When we divide 132, we'll get 66. So that angle is equal to 66 degrees. The angle subtended at the circumference is half the angle at the center of a circle by the same chord. Therefore, with these angles now, we can say that inside a triangle, we need to get 180 minus all the angles that are available, 60, 66. Wait, let me consider the triangle clearly. You're almost getting angles adding up to more than 60. Okay, 36. 36. I'm considering triangle ADE. Yeah, triangle ADE. So 36, 66, and 60. 36, 66, and 60 to get the remaining angle. This angle is now going to be 180 minus 36, 66, and 60, giving us exactly 18 angles in a triangle. They are supposed to add up to 180. Angles in a triangle add up to 180. That is the simple approach that you had to give to the angle properties of a circle as displayed in this particular question. Very good setting, very good setting. Let's get to part B of this. In part B of this, what have we been told? It's also given that AX equals to 12. That's now distances. CX equals to 4. BD 14. DE 15. Calculate DX, calculate AX. So let's check AX 12. I can clear up the time, the table or the diagram, sorry, so that now we may indicate the distances. Let me clear up like that. Then now we are talking about AX 12, A to X 12, then C to X, they have given it 4. Then what else has been provided? BD 14, B to D, BD 14, the whole of BD is 14, like that, and DE 15, D to E 15. Yeah, D to E is 15. What are we finding first? The length D to X. So length D to X, we can let it be X. So that X to B is now 14 minus the X that we have already eliminated. So we are supposed to know that when chords are intersecting internally, if it's this case, for example, AC and BD are intersecting at X, now the product of A to X times X to C should be the same as D to X, X to B. So now we have 12 by 4 being equal to X by 14 minus X, that way. So this is going to be 12 by 4 gives us 48, remember? Then 14X minus X squared, actually. This is our quadratic. Let's solve it. So X squared minus 14X, I've brought them to the left. So that, so that we have minus, is it minus? No, positive, because 48 is already to the left. We remain with a 0 like that. So we need the factors whose product is 48. Factors whose sum is negative 14. Let's talk about negative 8. Negative 8 and negative 6. Negative 14. Then negative 8 by negative 6. 48 positive. Yeah. I think we have what we need. We already have what we need. So with that, now we can continue solving this particular quadratic. This particular quadratic can now be finished. We say X squared minus 8X minus 6X plus 48 equals to 0. From the first pair, X will remain with X minus 8. Then here we subtract 6 to remain with X minus 8 equals to 0. So X minus 8, then X minus 6 equals to 0, like that. The value of X is either 8 or X equals to 6. Okay, we have two positive answers. Two positive answers. But now we are supposed to use some logic in this case now. Yeah. We use some logic. Okay, allow me just apply some logic. We know very well the diagram has not been drawn to scale. And when it is not drawn to scale, and we know very well that we are having D to B being 14, then I will let this one be the 8, and the other part here becomes the 6. Because logically, dx seems longer than x to b. So logically there, we can settle to dx being 8 centimeters. But since the two values of x are positive, the mark will go to either of them. But logically, I will work with 8 for that particular case. I would work with 8 anyway. Yeah, I would work with 8. So this is 8 centimeters. Can also be 6 centimeters. A to E. Distance A to E, the whole of that distance. Again, this is an external intersection of a chord and a tangent, whereby we say, you know, this length is not known, and we can let it be x. Or we can use another unknown. X is tired. Let me use y. Then we will say the whole of the chord A to E. When I take A to E, and I multiply by the outer portion, which is a C to E, I should get the same as the tangent squared, DE squared. So this is unknown, but we can let it be what? 12 plus 4, 16 plus y. 16 plus y times y should give us DE squared, which is 15 squared. Yeah, 15 squared. That's it. 15 squared. That's it. Then we can expand here to have 15y plus y squared being equal to, we square 15 and get 225. Square and get 225. Let's check. Let's check these. Y squared plus 6y equals to 225. I want to use a different approach. Instead of the factorization method that we've already worked, we can use the completing square method. So we add a constant here, and we also add it on the other side. A constant such that the left-hand side becomes a perfect square. So how do you make an expression a perfect square? P, a constant, is given by b over 2 squared. So b over 2 is 6 over 2, and we square. 6 over 2 becomes 3 squared, 9. With that, we'll be able now to, with that, we'll be able to talk about, the square root of the factorized form. To factorize a perfect square, we take the square root, the sign that follows, square root of this part, squared, equals to 225 plus 9, giving us 234. Okay. I want to hope that I'm organizing it well. I just want to hope that this one, no, remember this became 16. Sorry. This was 16. Why not 6? 16. Therefore, we should talk about 16 over 2, then squared. 8 squared, 16 over 2, then we square 64. So we are adding 64 and also 64 here. Sorry for that. Then now we factorize the left-hand side first, whereby we need the square root of y squared, sign that follows, and 8 squared equals to, we add 225 to 64, we get 289. That way. Then now we can talk of square root for both sides, y plus 8 being equal to plus or minus 17. So at this point now, the value of y shall either be 17 minus 8, which is 11, or negative 17 minus 8, which is negative 25. And this will have us settling at the value of x. I'm checking well whether 17 minus 8 is 11, but that's 9. Then now the value of y we settle at 9, because the other y is being negative. Length cannot be negative. So if y is 9, what add we let to be y? This part is 9. So what about the whole length of AE? 12, 4, 9. 12, 4, 9. 12, 4, 9. When we add 12, 4, and 9, we are getting exactly 25 centimeters. This is a very serious paper. Kindly invite a friend. Remember, after this video, this paper will still be available in the same channel through the same link. So kindly find some time, get back to the channel, review, understand what you did not understand. Otherwise, thank you so much for being around. See you another time for the section 1. Thank you.